So as you can imagine, the transducer is important for generating and detecting ultrasound. So in this webinar, we learn what is the physics by which they do that, the physics by which they generate and detect ultrasound, and we'll also be looking at their construction. And in the next session, we'll see some more about the spatial resolution of transducers, as well as some other factors involving transducers again. So transducers generate and detect ultrasound. Here are a few pictures of transducers. These are images taken from LBN Medical. And let's get right into it. So before we continue with the session, I'd just like to ask a question to the group. So what features of the transducer come into play, or what factors would you think about when you select a transducer for clinical use? Could you put that in the chat box? What features of the transducer would you think about when you select one for clinical use? Can you put that in the chat box, just so I get an idea of what you think about what features? Yeah, frequency, of course, yeah. Are there any others that you can think of? So I'm talking about factors of the transducer itself. So any factors of the transducer that anyone can think of that would decide whether we select a transducer for clinical use. Don't be afraid to put in the wrong answer. That's absolutely all right. But it would be great to get some answers in the chat. The dimensions of the transducer, that's correct. Anything else? Okay, so I'm not seeing any more answers coming in, so we'll go straight to the answer. So these are the factors which, okay, I got another one, 2D or 3D. Okay, so these are the factors that we look at when we're discussing transducers. So the weight of the transducer and the cable is a factor for the operator. Flexibility of the cable is a factor. The ease of cleaving, the shape and ability to grip, electrical safety, smoothness of the face, and appropriate length and curvature of the face. So these are all factors that come into play when we're deciding what transducer to choose. However, the most important factors include, so sorry about that. The most important factors include frequency, depth of the lesion, the dimensions of the transducer, and whether it's going to create a 2D or 3D image. So those are the correct answers, and we did get those in the chat. So let's keep going. So first, let's look at the physics of how transducers work. And it works using something which is called as the piezoelectric effect. Now, what happens in the piezoelectric effect is that you have a material whose dipoles are aligned. And as a result, this material is able to convert mechanical energy into electrical energy and electrical energy into mechanical energy. So what do we mean by mechanical energy? We mean things like pushes, pulls, shoves, pinches, basically something that's applying pressure on the object. And by electrical energy, we mean that it will develop a voltage, which is something that causes electrical charges to travel. So we have voltage in our houses, for example. Yeah, so that's that. So you can just see in the image on the left here how the piezoelectric effect works in quartz. So when there's no stress, there's no, the charges are not aligned. However, when there's tension, you can see that all those plus charges have lined up at the top and all the negative charges have lined up at the bottom. So this creates a voltage which causes electrical charges to move in a certain direction. And this happens whichever way it's being pressed. So it might be being pulled, or it might be being compressed, but both of those movements are going to cause a voltage to be developed. However, the voltage will go to the opposite direction as the direction of the pressure changes. Similarly, if you apply a voltage to the material will either compress or expand. So that's how the piezoelectric effect works. So materials deform on experiencing voltage. So if we apply a voltage, that is, if we put a positive voltage at one end and a negative voltage at the other end, then the material is going to change its dimensions. It's going to either compress itself or expand itself when it experiences a voltage. Similarly, when pressure is applied, material develops a voltage. So I hope that's clear. So let's watch a video of how this happens. So he has a piezoelectric material here, and he's going to hit it with a hammer, thereby applying pressure. So you can see a voltage is being created and charges are traveling. So he'll switch off the lights in a second and it'll become even more clear. Oh, sorry. I hope everyone's able to hear. He's just hitting it with the hammer. So we saw what's happening in that video there. He hits the piezoelectric material with a hammer, thereby he's compressing it. Then a charge develops, which causes voltage develops, which causes the free charges in the area to move in that line, which is why we saw that lightning-like effect when he was hitting it with the hammer. So once again, piezoelectric materials can convert mechanical energy to electrical energy and electrical energy to mechanical energy. Okay.